Hello everyone. In this video, we are going to look into secant-tangent angle theorem. Before we jump into this theorem here, let's define these two words first. So if we say tangent, this is the blue line right here. It is a line that touches the circle at one point only. We call this as the point of tangency. Now, secant is a line that touches the circle twice. And to make a difference between secant and a chord stops on the circle. It doesn't go through the circle, but the secant will go through the circle. So the line will extend out of the circle. So that's the difference between a secant and a chord. And the difference between a tangent and a chord is that tangent touches only at one point, secant touches at 2 points, but to make a difference with a chord, it goes through. Okay, so we have here the first theorem for secant-tangent angle theorem. This applies when the angle is on the circle. So we are looking at an angle ABC. So that's angle ABC. So if I were to label this angle right here in blue, so this is angle ABC. So we are, the angle is made up of a tangent BC and a secant AB. So this secant and this tangent. Now there's a formula that would work for this. The general formula for this type of angle where the angle is on the circle and it has formed this intercepted arc in red. The angle on the circle is actually half the intercepted arc. So for example, if this arc is 100, this angle is 50 because the angle is half the intercepted arc. Now let's have an example to better see how this formula works. So we have here this example right here. So I will put the formula that we got from the first slide up here so we can use it in this example. So we set up our equation. We're supposed to be solving for this is supposed to go through here. So we're supposed to be solving for x, which is the intercepted arc. So then we can go ahead and set up the equation using this one right here. Angle here is 77. So I go ahead and write 77. That corresponds to the angle on the circle is equal to 1/2 of the intercepted arc, which is the x. So I'm just going to go ahead and write x. Now we want to solve for x. In order that we can get rid of the fraction 1/2 here, we are going to multiply both sides by 2. So multiply this by 2. So if you multiply that by 2, we can get rid of the 2 and the 2 here. So we are left with 77 times 2 is 154. And that is equal to x. So the measure of this angle is 154, and that makes sense because 77 is half of 154. At this time, I would encourage you to pause this video and try this problem up here, and when you're done, unpause it and check your answer. Okay, so we go over the problem here. So it's pretty much the same thing. We plug values into this. So our angle is x this time. So we write the angle, again, this formula right here. So x is the angle is equal to 1/2 of the intercepted arc is 126 degrees. So that is times 126 degrees. So pretty much it's pretty straightforward. Half of 126 is 63 degrees. So this angle right here is 63 degrees. And that makes sense because half of 126 is 63. Did you get the same answer as this? Good. Perfect. Now let's move on to the next part or the next theorem right here. So it's pretty much the same thing. This is a secant-tangent theorem. So in this, this is our tangent AC and our secant is AD. So we have this theorem right here. The measure of the angle formed by a secant and a tangent from a point outside the circle. So the point that we're referring to is A. So when this secant and tangent are going to meet at a point outside of the circle, then this formula would work. The angle is equal to the far arc, so I labeled it far arc to make a difference between the arc that is close to the angle. So Far arc, others are going to say, what do you mean by far arc? So from the angle, it's far from the angle. So it's an arc that is far away from the angle. And this arc right here in orange is the one that is close to the angle. So I just labeled this as the near arc. So the angle measure here, which is located on the outside of the circle, is actually equal to far arc, whatever the measure of the far arc in degrees, minus the measure of the near arc divided by 2. So in this problem right here, we have the measure of angle A. So this angle right here is A, is equal to measure of arc DC, which is the far arc, minus BC, which is the near arc. Now let's have an example to better see how this formula works. So let's take this example right here. Okay, so let's take the first one together. So again, the formula for this secant-tangent theorem, I will put this up here because we're gonna use that in solving for these two problems here. So we have the tangent, we have the secant. So we are going to plug the values into this equation. So first we have the angle. So our angle is x. So that's x is equal to, then we look for the far arc. Far arc is far away from the angle. So that would be 100 and, so this is our far arc, this is our near arc. So that would be 124 degrees minus near arc is 58. So I'm gonna write 58 divided by 2. So if we subtract 58 from 124, that would be 66 divided by 2. So our x is 33. So this angle right here is 33 degrees. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So it's pretty much the same thing. We have the tangent here. So this is our tangent. And then, so I'm just going to put the equation up here. So this is the tangent. This is the secant. And we're looking for x. We're given the angle 34. So we use the same equation. I just move it up here so we can see how the picture look like. So this is our far arc. So in this problem right here, we are supposed to plug in the value for 34. So that would be 34 is equal to, our far arc is 132. So that would be 132 minus our near arc is x divided by 2. Now, in order that we can get rid of the denominator 2 here, we are going to multiply both sides by 2. So multiply this by 2. So if you multiply one side, I will multiply the other side as well. So then we can cross the 2 out. I can cross this 2 and 2 here. So we are left with 2 times 34 is 68 is equal to 132 minus x. We want the x by itself. So we're going to subtract 132 from both sides, minus 132. So then we can cross the 132 out. We're left with negative x is equal to negative 64. Now, we want a positive x, not a negative x. So then we are going to divide both sides by negative 1. Divide this by negative 1. So we can cross the negative and the negative. So then our x is a positive 64. So that would be the value for our x. And we can check that out by plugging it. If we plug this x back into the equation here, so let's see if that would work. So let's check. So that is that equal to 34. So we're not sure yet, but then the outside or the far arc is 132 minus, that's 64, and then we divide this by 2. This would come out 68 divided by 2. So that is 34 is equal to 68 divided by 2 is 34. So then the x here is 64. Did you get the same answer as this? Good. Perfect. Now let's move on to the next problem right here. So this time around, we are given expressions. So how do we find the angle, the far arc, and the near arc? Again, it's pretty much the same thing. We use the same equation that we have up here. So I will put that up there because that would be the same equation that we're going to use here. So as you can see here, our RS is the tangent and our RP is the secant. So this would apply, the one that we apply here would be tangent secant or secant-tangent angle theorem. So we put in the values. First, we have our angle here is 3x plus 20. So that's the angle. So that's 3x plus 20 equals, that is our far arc here is 10x plus 70. So this is gonna be 10x plus 70 minus, we have the near arc is, I'm putting it inside the parentheses, that means they're together, that's near arc, so that is 8x minus 10. And then this is divided by 2, so we divide this by 2 here. So then we can go ahead and distribute this negative to each term inside the parentheses. So distributing this inside the parentheses, this would come out to be 3x plus 20 equals 10x plus 70 minus 8x plus 10. And then that is divided by 2. Now, in order that we can get rid of the denominator 2 here, we are going to multiply both sides by 2. So multiply that by 2. We do the same thing on the other side over here too. So I multiply that by 2. So we can distribute the 2 here. So I'll distribute the 2 to each of the terms inside the parentheses. This would come out, we can cross out, by the way, the 2 and the 2 here. So this gets crossed out. So then this would come out 6x plus 40 equals, we're combining like terms. So first we have 10x minus 8x is 2x. So I'm going to write 2x here. And then we have, that's going to be 70. And then that's plus 10. So that would come out 80. So that is 2x plus 80 on the right side of the equation. So then that's 80. So 2x plus 80. And then from here, we are going to subtract 2x from both sides. So minus 2x minus 2x. So then we are left with 4x plus 40 equals, left over here is 80. So then from here, we are going to subtract 40 from both sides. Subtract 40 here. So we can cross out the 40 and 40, cross this out. So we are left with 4x is equal to 40. And then we divide both sides by 4. We divide this by 4. So our x is 10. That's our x is 10. And then, so x right here is 10. Now we're looking for angle R. So this angle R right here. So to do that, we plug this 10 into the equation. So that would be 3 parentheses plus 20. And then again, our x here is 10. So we can go ahead and this is 3 times 10 is 30 plus 20. This is 50 here. So I'm going to write 50 degrees for the angle. Now let's find the, so this is angle R is 50. Now we're looking for measure of arc SQ. So this angle right here. To do that, we still have to plug it in. So that would be 8 times the value of x is 10. So that would come out 80. So that is 80 minus 10 is 70. So this near arc is 70 degrees. So SQ is 70 degrees. Now we're looking for SP, which is the far arc. Again, to do that, we are going to plug it in. So 10 times the x is 10 plus 70. So again, the x here is 10. So 10 times 10 is 100. So 100 plus 70 is 170 degrees. Okay. So these are the values. So this is a measure of arc. SP is 170 degrees. Now let's check if this would work, because you see all of them are in expression form. So it is imperative that we check it to see if are they really equal to each other. So our angle is 50. So we got 50 and we are not sure yet if they're gonna come out equal. The far arc that we got is 170, and then minus the near arc is 70, and then that is over 2. So that's part of the equation divided by 2. So 50 is that equal to 170 minus 70 is 100 divided by 2. So then we go ahead and say 50 is actually equal to 50. So they are just the same. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!